Thank you. Delighted to be here. Wonderful to be back at Oxford. And I'm especially pleased about the topic of this year's conference because this is a subject that's fascinated me since I was a little girl. And you know, machine learning and AI now is being applied to virtually everything. It's interesting. If you go to Silicon Valley these days, you go to a startup pitch, pretty much every company says they're doing machine learning, AI, or some combination of the two. So we're finding that it's not just about adding pixie dust. This really is transforming industries, and it's also transforming innovation. So that's what I want to talk about today. And by the way, I'm going to speak for about 20-30 minutes and then leave plenty of time for Q&A. And I'm also happy to talk about the experience of starting and building companies. I'm a serial entrepreneur in Silicon Valley. I led the launch of Java at Sun, so I've had a lot of experience in all the ups and downs, joys and challenges of building companies. So happy to talk about any of that. So as I mentioned, I've been fascinated with this topic since I was a kid. And when I was a little girl, my mom would take me and my best friend up to a place nearby our home called the Lawrence Hall of Science in Berkeley. And at the Lawrence Hall, they had these computers in the basement, these mainframes, running a program called ELIZA. And ELIZA was like a virtual therapist. You could actually carry on a real conversation with ELIZA. And ELIZA would say, "How are you feeling today?" You would respond, "I'm not feeling great. My brother took my toys. Why did your brother take your toys?" And it would be a real conversation. At 10 years old, this was fascinating to me. And not only was it interesting that a computer could have a conversation, but I also loved to kind of force ELIZA into conversational dead ends. So I saw the limitations as well. Now, it turns out that ELIZA was actually developed a long time earlier. It was one of the first demonstrations of natural language processing, really a seminal development in the history of AI. So this kind of set me on a course in my life that led to actually my first job in Silicon Valley. This was in the mid-'80s. And this was the first wave of commercial AI. So my first job out of college, I was a biophysics major at Berkeley, studied computer science at University of Washington. My first job was at a company called IntelliCorp. And IntelliCorp was kind of like Google back then. Everyone had PhDs. It was a very exciting place to work. We were working with some of the biggest companies in the world, helping them solve some of their most challenging problems. And this is a representation of a knowledge system. That's really what defined AI, expert systems, the commercial AI market back then. We were trying to encapsulate the knowledge, the expertise of a given domain, and basically create an ontology. So define, capture everything that we knew about a particular topic. The top here is an example of trying to break down the representation of every object in the world. So you start with a physical object, then there's buildings, statues, things owned by Paul, et cetera, et cetera. The bottom diagram is actually of a nuclear reactor. And this is one of our customers was a consulting firm working with the nuclear energy industry shortly after 3 Mile Island. And we were trying to figure out how to avoid similar disasters. So again, trying to anticipate every scenario that could occur and avoid the problems from occurring again. So that was really the state of the art in the mid-'80s, and it was a thriving market. The commercial AI market was extremely hot. But then we descended into the AI winter, not dissimilar from so many technology waves where there's so much excitement and promise early on, and then disappointment when all the grand visions were not immediately realized. And then ultimately we ascended from that. But during those 20 years, the reason that we descended into the AI winter was first the cost of the hardware and the software. So the hardware itself was $60,000, $75,000 workstations. The software cost about the same. So you're talking about hundreds of thousands of dollars per employee just to implement this as a customer. So only the largest companies in the world could afford this, and it really wasn't scalable. It wasn't ready for prime time. And by the way, that also gave me, as a first time, this is my first company in the Valley, it gave me an understanding of the difference between great technology and market readiness and commercial success. So that was a very important lesson and kind of a tough one. The other thing that was challenging was you really needed special expertise, this ability to capture the knowledge of a given domain. Not a lot of people had that. So wasn't ready. But again, fast forward another 20 years, and here we are. AI is bigger than ever. Seems like every week there's another film coming out. AI is everywhere. And as I mentioned earlier, it's not just pixie dust. What really is happening is we're seeing innovation transformed everywhere. The reason is, what changed? Well, 3 billion people came online. And now we have massive amounts of data from which we can infer patterns and learn, essentially by looking at what people do, how they buy, how they search, what they say when they speak into Siri. And the more information, the more data is in the system, the more patterns you can actually identify and then apply those to making the system work better. And so this is really what machine learning is. Feed in a whole lot of data. You develop an algorithm to identify the patterns in that data. You observe the behavior, apply the algorithm, and then reinforce what works, throw out what didn't work, and then do it again, and again, and again, and again. And that's why Siri gets smarter. That's why Google search gets better. And this is possible to apply to pretty much anything. And in fact, some tasks are too complex to program. This is an example of such a task. So researchers at Stanford University actually have taught a helicopter how to do stunts by letting it teach itself and by observing what other helicopters are doing. This is an example of a helicopter flying upside down. This is not something a developer, a programmer could possibly write a program to do in advance. This is only something that can be done through observing, learning, and perfecting the system. So this is why we're seeing such incredible breakthroughs. And we're really on the path now to being able to approach human capabilities, because for years, what was easy for humans was hard for computers and vice versa. So computers have always been really good at calculations since the very first calculators, but really bad at stuff like recognizing images and understanding speech. Now, that's changed, of course, and Google really pioneered the first mainstream example of machine learning with its search algorithm. Facebook today with Deep Face, which is a new feature it rolled out not too long ago, can recognize photos with about 97% accuracy. So you don't even have to identify who's in the picture. Facebook does that for you. And of course, Siri gets better and better the more we use it. So we're using machine learning every day, even though we might not even be aware of it. And not only in how we operate, how we use our online search and buy stuff, but also pretty much everywhere you look. So machine learning is being used to detect deep earthquakes and exoplanets, to plow through reams and reams of research papers and identify discoveries, to make doctors better at what they do, to help surgeons perform better. Everywhere you look, self-driving cars, machine learning is being applied. And where we're really seeing AI go in its first mainstream, the regeneration of the AI industry and the mainstream applications is in this area of cognitive assistance. So instead of replacing people, because a lot of discussion these days is about, will computers replace us? Is AI out to basically replace humans? Really what the focus is making us smarter and better at what we already do. And of course, IBM with Watson is focused there 100% today. They have created basically a massive engine to calculate and learn from seeing how humans do tasks. And they're applying this first to healthcare in a big way. Ginny Romney, the CEO of IBM, recently said in the future, every decision that mankind makes is going to be informed by a cognitive system like Watson. It might not be Watson, it might be another type of cognitive system. But this is a pretty grand statement coming from the CEO of IBM, and they're really transforming the company around Watson and creating, by the way, a platform for startups. They've launched a $100 million venture fund for cognitive apps. So if you're starting a company and you want to work on Watson, you've got a great partner in IBM. And again, lots of other companies are working on this stuff too. But real money is being poured into this. And in the case of healthcare, one of the biggest challenges, of course, is no doctor can possibly diagnose every disease. No surgeon can know exactly what to do when things go wrong. And so what Watson does is offer this idea of decision support. It provides knowledge, expertise, guidance, so that when a surgeon is performing a surgery, that doctor is being assisted by 10,000 other doctors, and learns from failures as well. So that's the most kind of compelling element, I think, of this system, is you learn more from what goes wrong than from what goes right. And I know that's the case in startup world. I can tell you from experience. And so that's one of the most exciting areas is cognitive assistance for individuals. But what about when you apply AI to empowering groups? This is one of the next frontiers that's developing. And in fact, what we can do is very large-scale brainstorming. So let me give you an example of that. This is not a new concept. In fact, back in around 2002, Lego used this to innovate on product design. So they were trying to figure out what product to bring to market next. And they used a technology from a little startup company called SVCO, and that technology enabled tens of thousands of kids and parents to brainstorm about what they liked and provide that feedback, what they wanted to see in Lego. And it turned out what they liked was not just buying a Lego set and quickly building a toy, but they wanted to have a deep experience that was actually a multi-day intensive experience, and they were willing to pay for it. And so from that learning, the Lego developers and designers brainstormed internally and came up with the Star Destroyer. And so instead of paying $50 or $100 tops for a Lego set, suddenly people were willing to pay $300, $500 for the Star Destroyer, and it has become one of their most popular product lines. It's really helped transform that company. So this stuff really works. But again, just like back in the first iteration of AI in the 80s, this technology wasn't quite ready for mainstream adoption back at the beginning, around 2002, because this idea of tapping into social media and engaging your customers was a very new idea. We didn't have 3 billion people online, and only the biggest, most innovative brands really were willing to try that kind of an experiment. Most brands were afraid of engaging with customers back then, not too long ago. Of course, that's changed completely. Every brand now wants to connect and engage with customers. And now, again, we have the ability to do that. By the way, they sold out of their first year's inventory in 7 weeks. This was just an extraordinary experiment that was very successful. So this idea of using AI and massive brainstorming is actually being applied to some very interesting areas. And I'm part of a company, a startup company. It's called CrowdSmart, chairman of it, that is focused on helping entrepreneurs build better startups using massive brainstorming and actually tapping into communities of alumni and expert advisors. And so the goal, of course, for any entrepreneur is to build as fast as possible a fundable company. And one of the biggest challenges is product market fit. I mean, that 80% of startups fail because they don't get product market fit right. The problem is you need to get a lot of data. You need to gather a lot of input, and it's hard to do that. In the lean startup approach, which many of you familiar with the lean startup approach, that has been a really, I think, very powerful tool model in enabling entrepreneurs to get outside the four walls of their building and actually engage with customers and partners or prospective customers, partners, and investors. The problem is that it's hard to scale beyond about 100 people. So this is about the next step beyond the lean startup. This is about engaging with thousands or even tens of thousands of experts and knowledgeable advisors. And of course, the advantage also for the university is to bring and engage those alumni. So you have a wonderful opportunity to create some symbiosis here. The way that it works for the entrepreneur is they get an investment readiness score, basically. And the investment readiness score gives them an indication of whether they're there yet, whether they've figured out that magical product market fit, among other things, or not, whether they have to go back to the drawing board and iterate. And this is an example of, for example, the kind of feedback that entrepreneur would get. They might get information about, was this story compelling? If not, why wasn't it compelling? What would you do different next time? And from the standpoint of the advisors, the alumni or the experts who are helping the entrepreneur, they get questions that they can provide ratings by answering. So again, was this pitch compelling? If not, why not? And not only do they have the ability to answer the questions or pick from a list of responses, they can also enter their own input. So this is an open-ended brainstorm session. This is not just about rating and ranking existing answers. This is about inputting your own. Where the machine learning comes in is when you have thousands of people doing this, you have the ability to create a very predictive, repetitive result again and again where the best ideas rise to the top. So you can predict over time very precisely what basically the crowd, the wisdom of the crowd said. And when you have a group of experts, knowledgeable people who are giving you feedback, that can be incredibly valuable. So this, again, is really aimed at speeding the rate at which that process happens. Every startup goes through it. This is about accelerating it and making it much more accurate and predictive. So how is this different from, say, SurveyMonkey or Reddit or Quora or any of these other tools that exist? Well, with survey tools, answers are confirmatory. So you've got basically a set of answers, it's questions that you're answering, but that's the structure of the engagement. With Quora or Reddit and tools like those, that's an open-ended discussion. The challenge, though, is making sense of the reams and reams of answers. And there's no way of really identifying from all of those answers what truly the best ideas were, because you can vote yes or upvote everything. There's not a good way of analyzing all of the input that comes in. So this is really about making sense of input and advice and doing it in a very scientifically predictable way, again, using machine learning, where the system gets better and better at this over time. I like this quote by Yo-Yo Ma. He says, "The most interesting stuff in life happens at the edges and the intersections." And we're really seeing this play out with machine learning. Machine learning really is pushing the boundaries, the edges of discovery in virtually every discipline, as we've talked about. And it's also being applied to the intersection of disciplines. And this is where you begin to see the human-like qualities being integrated into these systems. This is where some of the most interesting research and development is happening. So the intersection, of course, of the reason that we're here today in this conference, among other things, is to focus on this intersection of intelligent machines and humans. And the real frontier here, one of the frontiers, is making robots and computers act more human. There's a researcher, came out of MIT, Guy Hoffman, who's been doing some very interesting work in this area. He calls it robots with soul. And if you go online, there's a TED Talk that's really interesting. He's got robots that actually react in real time to music. They're bopping, they're kind of actually moving in a way that is very human-like. And they're jamming with a musician. And the experience is really extraordinary when you see a robot acting like a real human for the first time, because we're used to them kind of walking like this and talking in a monotone voice. That very soon will be robots of the past. Very quickly, we're going to see robots that truly seem human. And he did an experiment where he had a group of people, and he had robots help those people with a simple task. It's about a 20-minute task. And one group of robots did things the same way every time, very rote. The other group of robots experimented. They would try things, maybe they would fail, but they would try different approaches to solving that problem, working with the humans. And at the end of the experiment, people who had the opportunity to work with the experimental robots who took risks actually developed an emotional connection to those robots. They called the robots he and she instead of it. These were not human-looking robots, by the way. They looked like kind of a knob, but they actually developed an emotional connection to the robot. And they even said things like, by the end of the session, we were doing mental high fives together, us and the robots. They felt like there was a relationship that had developed. And in contrast, the people who worked with the robots who did things by rote called them lazy apprentices. They had disdain for those robots. So this idea of human engagement is very powerful. And the way that Guy Hoffman is approaching this, I think, is very interesting. He's actually studied method actors. He's studied jazz musicians and artists and animators. And you think, for example, method actors, they don't predict in advance everything they're going to do in a scene and the way they're going to react. Method acting is all about reacting in real time to the other person you're engaged with in a dialogue. And you're bringing your stored memories. You're bringing your emotions. And sometimes things work, and sometimes it works, sometimes it doesn't work. But the power that you get and the effectiveness of a method acting approach can be much better in many cases than the sort of predictable approach to acting. That's just one example. Jazz musicians, similar. Jazz musicians play, they don't necessarily know what they're going to do next. They make it up as they go along, like we often do in life. And that human-like, that capability of experimenting, trying things, failing, but doing that in real time and then taking those learnings and feeding that back into the engine is really where machine learning will be applied next in some very interesting ways. Now, imagine if Siri not only could understand what you say, but understand how you feel. That would be pretty amazing. And again, we're on the frontier of exactly that. So where Guy Hoffman was teaching robots how to move with grace and act in terms of their actions human, new systems are being developed now to provide emotional response. And the way this is being approached, one approach, is to actually break speech down into biological motivators. It might not be very easy to see here on the screen, but it turns out there's sort of about 8 to 10 main biological motivators in speech and in life in general. And speech can provide patterns, that, clues to those biological motivators. Those motivators are things like the need for survival, the need for intimacy, the need for power, the need to communicate. And the way that you express yourself, the words you choose, the phrases you choose, are very powerful indicators of how you actually feel. And we know that because as humans, we instinctively know that. Now we're beginning to teach robots and computers how to do that by breaking down human speech. And you can break down those, say, 8 biological motivators into up to 500 subcategories of motivators. So this gets very complex. This is an ontology, basically a knowledge system. We're kind of returning to the 80s in a way by creating these, encompassing this compendium of information about a particular domain, in this case, speech and words. And then marrying that with machine learning by feeding into the system experiment after experiment. And you can imagine the amazing number of the wealth of places you can apply this. For example, a robot that could help an elderly patient who's feeling anxious, lonely, and know exactly what to say to that patient and exactly what to do in the next moment. Incredibly powerful. Now, as I mentioned, just mentioned a minute ago, machine learning alone is not enough. These knowledge systems are becoming an important part of really realizing the power of AI. And the European Commission has a research project that's very interesting. It's called Robo-Earth. And they're actually helping robots teach each other how to do tasks. Again, creating an ontology, a knowledge base, a Wikipedia-like set of all of the tasks that a robot needs to do. In this case, they're making robot servants that will help us set the table and do our laundry and so forth. And that knowledge base contains information about, for example, how to grasp a cup. But it might be that there are different size cups. And one robot might learn by trial and error how to grasp a cup that's tall versus a mug that might be a different shape. And when that robot learns that information, that goes back into that Wikipedia-like knowledge base, and other robots learn from it. So they're essentially teaching each other. And again, it's that combination of knowledge base plus machine learning leads to incredible transformation and human-like qualities. Now, this might sound scary. Armies of robots that are figuring out what we might want to do next. And I think there's good reason to have some healthy concern and awareness of some of the implications of how AI can be used. And we've talked a little at this conference. If you were here yesterday, you heard perhaps Nick Bostrom speak or the opening keynote. Elon Musk has been famously quoted recently as saying AI is essentially, we're summoning the demon as we're developing these technologies. He's sounding a very strong note of caution. Stephen Hawking believes it's a race between the power and the wisdom, the power of technology and the wisdom with which we use it. And Nick Bostrom has made the point that we really need to fund groups of people who are thinking about the macro implications, the societal implications of having robots or AI assistants that decide to do things before we might want them to do those things. And the importance of having AI safety experts work with AI developers. His point also is that trying to apply regulatory control over this domain is premature. We don't really know what we need to regulate yet, but we do need people, a lot of smart people, thinking about the implications of this before it gets ahead of us. And I think they're very wise. So as I mentioned, AI is transforming everything. It is changing our lives in ways we can't even imagine. And 10 years from now, the world will be transformed by AI. This is an area that, to me, is very exciting because I imagine, the Eliza of my childhood being a real therapist. I imagine computers making us smarter and better and more compassionate, and basically helping humanity solve its greatest challenges, not only problem solving in the kind of practical sense, but also dealing with our biggest social challenges. Obviously, there are huge issues we need to overcome. One of them I haven't touched on is jobs. What happens to jobs when computers, robots have the knowledge and the capability to do things that we're good at and many people have jobs doing? Well, the answer is obviously education and skills training. And so if you imagine a future where AI is everywhere, one of those scenarios is intelligent tutors to help us prepare for the next career. And this will be ubiquitous. We will have tutors basically creating the next set of knowledge, helping us understand what we need to know for the jobs that we need to get next as our jobs get eaten by the robots. It's a very much a process. It's an ecosystem. It's a process of evolving very quickly because this is accelerating. Skills development has to happen quicker because the jobs are disappearing faster than ever. And we've had, in fact, I was here at Oxford debating the authors of a book called Race Against the Machine, which some of you might have read, which laid out the dangers of a very rapid replacement, wholesale replacement of jobs by computers and AI and robots. Yes, that is happening, but we also have the power to learn, to gain knowledge quickly, and also develop and design new products and build new companies and invent entire new industries using this technology as well. So the opportunities are immense. This is an area that I'm very excited about, both because this is really what sparked my interest in computers as a kid, and where I think the most exciting developments will be happening in every domain of expertise. And so I wanted to just give you an overview of my assessment of the industry and the domain of machine learning and how it's transforming innovation. And I'm happy to answer any questions about either that or, again, the experiences of starting companies and building products and innovating. So with that, thank you.
Are there any questions?
Get the merit of being closest to the microphone. So I think it's really exciting. I share that excitement, especially as we get toward the artificial general intelligence development.
Yeah.
But the thing is, a lot of the ideas and the creativity around the applications are pretty dull right now. I mean, using AI to tutor you is not a novel application of human intelligence. It's just a replication of a human use case. So, right. Do you see a better development, a new pathway for just the field of creativity, and maybe even using AI to shape how we use AI to open up new doors that we hadn't thought of? And do you see that happening yet and in any certain directions?
Yes, that's a great question, and a couple thoughts come to mind. One is that the area of learning science we haven't really touched on, but there's a lot of work being done now in understanding how people learn and absorb information. So whereas the idea of tutors, intelligent tutors, is not new, a tutor that helps you get better and increase and accelerate your cognitive understanding of a topic, that is new. So that's one thought. Another is that, yes, the whole process of scientific discovery actually is being accelerated by AI. There are researchers working on getting better at plowing through immense amount of data. And we're seeing now breakthroughs, it's almost an iterative process where the process of discovery is being accelerated by AI. So I think you put your finger on something very important, which is this is not just about, faster computers and more data. This is about transforming cognitive understanding how the brain works. I haven't even touched on computer architectures, but for example, if you look at the next generation design of what IBM is doing and others, they're developing computer architectures, throwing out the computer architecture that we know today, and developing, this is future stuff, but developing an architecture based on synapses and neurons, basically the design literally of the human brain. So when you marry that with the kind of software and technology we're talking about here and new approaches to learning and cognitive understanding, it becomes incredibly powerful. And we, I think, can't even comprehend the speed of innovation that will happen when that occurs, which is not that far off, actually. So thank you. Good question.
I had a question on your previous backgrounds in startups. Like
Yes.
These days, there's a big talk about failures and to fail fast.
Yes.
Would you share some stories about your own experiences and what you learned from that?
Yes. So I don't know. I mean, it's very rare to find an entrepreneur who has not been through not just one failure, but multiple failures. It just goes with the territory. I'll give you an example of an early failure and how that shaped me. I was on a team called the Oak team. It was a technology at Sun Microsystems had been developed for this future networked world which didn't yet exist. So a team of brilliant engineers at Sun had gone to the CEO and said, we want to leave. Steve Jobs is recruiting us to go to Next and build this next generation software system for a future networked world which doesn't yet exist, which is crazy, sounds crazy, but because they were so talented, Sun CEO said, if you stay here, what do you need? I'll give you anything. And they basically spun out a separate company called First Person, and First Person took this technology, we built it. That team created basically the system that became Java. I came on board back when it was still Oak, and we attempted then to try to find a way to get this out to market. The goal was ubiquity. It was ubiquity or go home. There was no middle ground. And as a product manager for this technology, I felt immense pressure because I knew the power of this technology. This was pre-internet, this is pre-commercial internet, pre-web. And basically, we were failing. We tried first to deploy it on the set-top box, devices, wasn't ready for prime. Those devices were not ready for prime time yet. They were $20,000 Silicon Graphics boxes. The PDA market, now we call them smartphones, personal digital assistants back then. Newton was the state of the art. This was the first device from Apple. Again, not ready to run the software. And so basically, we were at the point where we were burning a lot of money and not coming out with a commercial product. And, not surprisingly, Sun was questioning our existence. Right at that moment, when things were really going south, Mosaic came along, the first web browser. And we downloaded Mosaic and realized that we could bring interactivity to the web. So up till then, web pages were only capable of hyperlinking to other text. It was just static text. You couldn't run a little program in a web page. Sounds like ancient history, but it's actually not that long ago. And when we developed, for the first time, applets, little apps that ran in a web page, it was revolutionary. What we did to validate this was we got some developers to build some really cool stuff. So for example, the first applets, you could run a mouse over the image of a human body and see MRI slices in real time and imagine doctors collaborating remotely and a spreadsheet that would calculate your net worth in real time, that sort of thing. That was revolutionary. We went in a single day, basically, from being on the chopping block to being the future of Sun. And what that lesson taught me, to your question about failure, was, it was a really tough time getting to that point. There was a core group that stuck with it, and because we believe so much in this technology. And it was a combination of incredible persistence, and if there was one, motto I would give an entrepreneur, it is persistence, tenacity. The importance of sticking with it. If you got something powerful that is incredibly valuable, the world needs, you don't quite know how to get it out there yet, sticking with it until you figure out how. Because circumstances can change around you, and you can basically have breakthroughs at the moments you least expect them. And so in that single day, there was an article that came out in the Silicon Valley Mercury News. It was basically transformational for Sun because we went from being this little skunkworks project no one knew about to, again, being really the future of Sun and transformed their strategy with the internet. So that's one example. Sticking with it, tenacity. If we'd given up, Java would not have made it out to the world. And that was a big, big lesson for me. Another, just a quick example is founding Marimba. So 4 of us left the Java team, founded one of the first internet enterprise software companies called Marimba. We were actually profitable within 3 years. We grew fast. We had real products, and we were, in fact, going up against IBM and competing very successfully against them, doing what is now referred to as cloud computing, server management, automated device management. Back then, it was pretty radical stuff. And then the bubble burst. We'd gone public. We were profitable. We had $60 million in the bank, and the bubble burst. And suddenly our market cap was 42 million and we had 60 in the bank and we had no debt. It was insane. The whole valley kind of went into this turmoil, and the industry, obviously. But the entrepreneurs stuck with it, and this is back to this persistence and tenacity point. We almost, basically lost the company during that period of time. There was some pressure to sell, which would have been really crazy from a valuation standpoint and from a potential of the company standpoint. But we rode it out. We ultimately had a successful exit and sold the company, and it was the technology today runs on Wall Street and major retailers all over the world. But again, tenacity, and then figuring out how to reinvent yourself. And we did that again and again at Marimba, and I've done that at every single company. It's really hard when you hit these skids, when you hit the skids, and you have to really look deep within yourself and get the will to go on. But it's something, again, every entrepreneur does, and if you have a dream, you have to dream big and stick with it. And it might sound trite, but I can tell you from experience, that's the only thing that works. Every single entrepreneur has gone through some moment where they had to have tenacity and power through despite the worst circumstances. So many, many stories about failure, but those are just two that come to mind.
Other questions?
To the point that machine learning has a lot of commercial applications and is very successful in that realm, it seems like a lot of the best minds in machine learning are being attracted to industry and joining the Googles and the Facebook research groups. And I'm wondering if you think that's the best thing for innovation in the field and where academia is appropriate.
Actually, I think it is a good thing. The fact that Google, Facebook, and others are valuing this area of knowledge so highly, I think is attracting more students, more researchers to focus on it. And it's not just the big companies that are hiring those people, it's also startups. It's, like I said, every startup pitch these days, everybody's talking about AI or machine learning. So I think what it's doing is causing tremendous investment in the area of machine learning, and it's transforming education. So I've spoken to a number of universities recently that are rolling out now new data science courses for not just computer science majors, but for everybody. I mean, whether you're a social science major or you're a computer science major, you need to know this stuff. It is transforming every industry. So, and I think universities are realizing that we need to train the next generation of students to understand how to apply this kind of approach to any domain, any industry. So yes, I think it's a good thing, and I'm hoping that we actually accelerate that process and get more money, more funding going into this, because if there's anything that has leverage, it's the application of AI to domains.
Okay. There was another question in the
Yes,
back,
in the back.
gentleman in the back.
Where do you see potential applications of machine learning in banking and finance? Do you have any ideas there? Or?
Good question.
We're talking about digitalizing business, but
right.
it's a vague thing. So what are the specific?
Right. Are you in the finance industry? Are you? Okay. And I'm curious, actually, if you have any thoughts on this as well. I've not yet seen any examples kind of along the lines of what I just described, but obviously one of the first examples that you could think of is just massive amounts of data and patterns and inferring information from those patterns. So fraud, potential for fraud, this is already being applied, AI and machine learning for things like detecting fraud. But I'm also hopeful that we can apply AI to helping people be better at, for example, saving money, making the right financial decisions. I'm now talking about on the individual consumer level. So the company Clearstreet I'm chairman of is a fintech company, it's a financial technology company that's aimed actually at the problem that in the US, 76% of the population lives paycheck to paycheck. And we're using behavioral science right now to get people on a path to saving and some new ways of approaching lending to help people pay off a debt. Exactly. So those are the areas where I think the debt problem is immense, and it is a huge drag, both on a micro socioeconomic level and also a macroeconomic level. And that's one of the first areas I'm hoping that the financial services industry chooses to apply this.
Okay, there was another question.
Yes.
Here. Maybe in the back and then
Okay.
in the middle.
Thanks for that, Kim. You mentioned the crowd. I forgot the
CrowdSmart?
Yeah, CrowdSmart.
Yeah.
That's it. Sorry.
Yeah.
Could you give us a quick pitch of CrowdSmart?
Yes, yes. So it's an early stage company. We're just in the process now of piloting the product that I mentioned, showed you some screenshots of, which is basically this massive brainstorming system for entrepreneurs and advisors. And we're working with the University of California, beginning to do some initial pilots with several other universities and getting feedback, basically. We're in that early stage, startup process of ourselves. We're going to be learning, using the system ourselves to figure out where we can improve and whether we've hit the mark or not. And what we're finding is incredible resonance at these universities and with the entrepreneurs, because every entrepreneur is trying to get there faster, and every university is trying to figure out a way to engage alumni. And there's amazing value that has not been unlocked in that relationship, and also amazing potential to apply many great minds very quickly to problem solving. And I think getting better startups out there faster is one of the best ways we can solve all of the challenges we face, as a society. So that's where we are, early stage, just beginning to go out. We just raised our seed round. So, we're, like many of you in the room, setting out on that tough path, but very rewarding path of getting a new company off the ground.
Maybe we can move. There was someone here. Oh, yeah.
So the undergraduate machine learning lectures in the computer science faculty are both, at the moment, completely oversubscribed. People are sitting on the floors in order to hear the lectures, and also really, really technical and difficult to understand. And I wonder how long do you think it will be before the technology becomes democratized enough that we don't have to hire PhDs in machine learning in order to use technology?
Yes, that's the question actually that really resonates with me, because I think this is stuff that everybody should be learning. And I'll just give you an example of a course that Berkeley and Harvard and a couple of other universities rolled out not too long ago. It's not a machine learning course, but it's called The Beauty and Joy of Computing. And they rolled this out to the entire undergrad class of freshmen and sophomores, and it's become one of the most popular courses on campus now. And it's because this stuff is just, computing and computational understanding, knowledge should be a standard course for everybody, just like English and, social science and history is. And in fact, not just at universities, but, all the way back in elementary school, and, kids should be learning this stuff. I think we just need to get smarter fast about how to teach it in a way that is comprehensible to non-PhD computer scientists. And that's entirely achievable. This is not that hard. And I was just talking with some colleagues at the University of California the other day about a new course they're planning to roll out in data science exactly for this reason. So democratizing the understanding of machine learning and AI and computational thinking is probably one of the most important things we can do in education right now. And by the way, there are also companies like Coursera and Udacity that offer courses in data science. I think Coursera offered a data science class for the first time, and I think they brought in like $8 million or some amazing amount of money just from that one class. I don't claim that as a fact. This is a rumor I heard. But they made a lot of money from this just first course that they rolled out in data science because there's so much demand for it. And with, I think, more and more online, educational resources, we're going to find that even if the universities don't get there fast enough, because universities are often very slow to move, the online education, the alternative options are becoming much more broadly available, and they're not aimed, all of them, at PhDs by any means. So I would encourage everybody who's interested in this to go online and look for these courses, because they're out there, and some of them are actually getting pretty good. And it's not, online education, by the way, one more thing I'll add, it's not just about, watching a video and then taking a test. The most effective examples and instances of online education bring students and teachers together in these virtual sessions where the students really learn from each other, and they're project-based, and so don't be discouraged by the idea of just watching a video. That's really the most primitive form of online education. The really cool stuff is when you get people together learning with each other, and then also the ability to track how you're doing, what are the challenges you're facing versus someone else in that same class, the way that you're learning, and the individualized instruction, which I think is incredibly powerful.
Perfect.
Thank you very much.
Sure.
Okay, well, I might make it a little weird and off topic, but a lot of the future of all this is it's going to be deeply disturbing to the way society is structured, right? I mean, if we go 15 years in advance, if this sort of accelerating innovation continues. So I think there's going to be a lot of struggle there, and I wonder how you think we need to deal with that, and if we can even let AI learn the history of human civilization and help guide how it has to accommodate and change to integrate AI, and what kind of hazards we're going to face and opportunities we might face, if you've given any of this.
That's a really interesting point, and this is a reason why I think we need social scientists and philosophers, studying and engaging with computer scientists and understanding machine learning and the implications of applying this technology. And in fact, in some of the examples that I was giving, it was about not only teaching computers to do tasks better, but making them more empathetic, helping them understand us better, what motivates us, what challenges we face, and creating more of a human-like, helper in ways that are not just about doing tasks. So you're right. I think the challenges are immense, both because, the potential for destruction from this technology, and also the erosion of jobs very quickly. So I would love to see a university start a program that's, in fact, focused on what you just said. And, I think some of the most forward-thinking universities are considering doing that.
Great.
Yes.
Hi, so I think it's a fascinating presentation. There's a lot of incredible opportunities, but then it's kind of interesting when you see a high-profile tech guy like Elon Musk say you're summoning the devil.
Right.
So I'm just wondering, from your perspective, what maybe misconceptions there are to the side of people who think that AI has massive inherent danger, whether there is a bit of a perceptive of that kind of on your side too, or what the thought is there.
Yeah. Well, I think, Elon's quote gets picked up because it is just red hot, and the press kind of amplifies this, and then when you have Hawking's and others chiming in, it kind of whips up that frenzy of they're here to replace us. We're going to have machine-killing drones like next year. The fears are immense. But when you actually listen to the full context of what most of these folks are saying, it's a balanced, it's a nuanced opinion. And I'm an optimist at heart, and so I see the good and the potential before I see the danger many times. But I'm, in this case, really thinking through a lot about the implications, the negative implications of this technology. I think a lot of the perception is they're going to replace us. In fact, the initial iterations of the application of AI is, the cognitive assistance. Nevertheless, the potential for, wreaking havoc is immense. One of the reasons, actually, that I've been involved in policy, one of the things I didn't mention is that I've been part of several groups in Silicon Valley that have been working on technology policy for now over 2 decades. And this is something that, as an entrepreneur, I didn't set out to do. In fact, I had no real interest in politics and policy back when I started my first company. But that process of going to Washington and sitting down and talking through and understanding how policymakers guide the decisions that they make and craft the legislation they do, and all the influences, that go into that, that understanding and that engagement in policy discussions is incredibly important for the technology industry, and I think something that we haven't done enough of. And I'd like to see entrepreneurs, for those of you in the room who are considering starting a company, and even if you're not, if you're going to work for a big company, whatever you do, consider getting involved in policy in some way, because your voice is important to have in the mix. And oftentimes, this is why I like what Nick Bostrom says. He says that we need not just the AI developers, but the AI safety experts, and a conversation around the policy and the application of this stuff in the biggest sense. So hopefully that answers your question.
Great. We have time for one more question.
Hey Kim, I liked how you emphasized opportunity at the end with the caution of what we just covered, and so I'm particularly interested in cognitive assistance, and I'm curious what you see, how you see that evolving from a new phenomenon to ubiquitousness throughout a variety of industries, and I've got a few in my mind right now, but I'm curious how you see that taking off. Yes.
Well, the application in healthcare really is just around the corner. And for example, just the immense risk of getting it wrong when a doctor is performing a surgery. And if they had the example of 10,000 other doctors who've done it for, well and not well, that kind of information is readily available now. And so I believe healthcare really is where we're going to see the first major impact and breakthrough, both in effectiveness of delivery of treatment and also in basically making better decisions and reducing the cost of healthcare as well. So that's one area. I think learning science and the whole area of education is another, and it's another one that I'm excited about, and again, for the reasons that we've touched on here, which is the concern about job erosion and importance of skills training and continually reskilling AI and expert systems and knowledge assistance in a whole variety of domains really will be, I think, transformational when it comes to addressing that issue, that challenge of job erosion. I'm curious what other areas that you see or are interested in.
I was thinking even down to the personal level and decision making. If you have
Yes.
assistants that can filter through historical data or your prior history of behaviors to help you in making more rational decisions that are less biased by emotion or what may have occurred yesterday, that
Yes.
has huge implications, and I think that's where my head's going with where opportunities might exist.
You're right. And actually, at many of the startup pitches, conferences these days, some of the most interesting companies are in the social sciences areas. So a lot of psychology majors and people from sort of the social science side are beginning to apply this technology to helping us understand ourselves better. Helping with for example, kids who are autistic and have challenges communicating with each other. Your point about making us better, about making decisions based on things we've done in the past, mistakes perhaps we've made, or people we might know that we should be, including in this decision, or experts we could tap into. Incredibly powerful, and again, not that far away. So this is where, when I think about the kind of startups we're going to see, and also products coming out of big companies, just even 5 years from now, it's very exciting, and it has the potential to change our lives in ways I think we don't quite understand yet, in a very personal way, to your point. And again, starting from my beginnings of being attracted to computing because of this virtual therapist, Eliza, that's one of the areas that really intrigues me the most. So thanks for asking the question.
Thank you very much, Kim. Thank you very much, everybody, for coming.
Thank you.